All right, in this video, we are going to work through one of the examples from the Newton assignment, graph, sine, and cosine functions. So taking a look at this example here, it says find the equation of the graph given below. Notice that the sine function is used in the answer template, representing a sine function that is shifted and or reflected. It says use the variable x in your equation rather than the multiplication times symbol. Okay, and so here's the answer. Here you can see that there are three blanks. One for the number that's outside of the sine function, and then there's a blank here inside the sine function, and that is going to be some function of x, and then a number out here as well. Okay, and so what we're going to go through and determine all of those values in there. Okay, and so I'm going to switch over here temporarily to a slide so I can mark on this. Okay, so looking here, they give you 2 points: minus pi over 2, 2, right, and 3 pi over 2, 2. And you can see that this represents one period of the function, right? So one period. And so what we can do is use these numbers to find the period, looking by the graph. So the period is going to be basically the length of this dotted line right here, right? The number of units in the x direction that it takes for one cycle to repeat. And so here you can calculate that by taking this rightmost point and subtracting 3 pi over 2, and that's the right x coordinate here, minus a negative pi over 2. All right, from those points that they give you. All right, and so when you calculate that out, that's going to be 3 pi over 2 plus pi over 2. So I need to add these two fractions. These fractions have a common denominator too, right? So I can just add the numerators. 3 pi's plus one more pi gives me 4 pi's. All right, and so that gives me 2 pi when I reduce that down. So that is the period. Okay. The phase shift, right, on these, and the way that they're going to do that is the way they give you these problems. And I'm not saying like, this works for every problem there that exists out there, but for the Newton problems similar to these, this is how this is going to work. The phase shift is just the x coordinate of this first point right here. So the phase shift is minus pi over 2. Okay, so that would be the next thing to determine. All right, and so we can get that from these 2 points. All right, so next up what we need is the amplitude and the vertical shift. All right, so let's go with the vertical shift first. Remember, that's also the midline. And so when we look at the graph, we can see that these points up here at the top, the maximum values, right, are at the y value of 3, right? So this point, they would have a y value of 3. And then the low points, or the minimum values, right, would have a y value of 1, right? So halfway in between 3 and 1 is 2. So the vertical shift here is positive 2. All right, remember, you can calculate that out. Now you can just kind of look at it and see, but remember, you can also get that by taking the average if you want to. The maximum value is 3, the minimum value is 1. And so when you average that out, you get 4 divided by 2 equals 2. Okay, so you can do it that way. And then the amplitude right would be the distance between the midline and the maximum value, or alternatively the minimum value, right? The distance between the midline and the minimum value. And here again, you can kind of see that that's just 1, right? You can see the high point here is 3, the midline's at 2, so the amplitude is going to be 1, all right? So that's the first thing that you want to do in this problem. Go through and get all of that information from the graph and put it in that way. Another way you can calculate the amplitude, right, is to take the high point, right, and subtract off the midline, right, and take the absolute value of that. So that would be absolute value of 1 equals 1. You can also do that with the midline minus the minimum value, which is 1, right? So that also, you see, comes out to be 1. That will give you the amplitude. Also, you could take the half, right, of the distance between the min and the max as well. Okay. All right. So that's the first thing to get those. But in the answer blanks, right, you got to be careful about this. It's not these things that they're exactly asking for, right? Remember, our format for these is going to be y equals a times sine bx minus c plus d. All right, and so the values that you put in these answer blanks, in the first answer blank, you're going to need to put a, the value of a. In the second answer blank, you're going to have to put bx minus c, right, in this second answer blank, and then you're going to have to put the vertical shift, right, in this answer blank here. Okay, so the easiest one of these is the vertical shift, right? This is just d, right? So d is the vertical shift. So there's really no calculating that you have to do. We know that the vertical shift is 2, so just put a 2 in here. Oops. In here, put a 2. Okay. All right, next up, let's go with the amplitude. So with the amplitude, right, we know that the amplitude is the absolute value of a. All right, and so we know that the amplitude in this case is 1 from the graph, right? We looked at it. So the absolute value of a is equal to 1. Well, that leaves 2 possibilities. That means that a could be equal to 1 or minus 1. Okay? And so you're going to have to figure out which one of these should I pick. Should I pick the minus 1 or should I pick the 1? Right? So what you want to do is the key, and they remind you, they say, hey, notice that the sine function is being used, right? And go back to this first point, the point on the left that they give you. You can see that they give you a midline point, right? And remember the sine, the basic sine, what does it do? The basic sine starts at the midline and goes up like this if the amplitude is positive. If the amplitude is negative, it's going to start at the midline and go down. So looking at the graph they give us, right, it's starting at the midline and it is going up, right? So that means that this one is going to have to be the positive one. So the amplitude, or the value of a in this particular one, is going to be 1, okay? So you're going to have to go back on that part and figure out on the amplitude and figure out whether you should pick the positive version or the negative version. And that's going to be based on that point that they give you. In this case, it's a sine and it goes up, right? So that would mean that it's like the regular sine function and that the amplitude should be positive. On the other hand, if it started at the midline and went down on that point that they gave you, then you would pick the negative one, okay? All right, now finally on to B and C, right? In here, we'll need to figure out what both B and C are. So remember the period is equal to 2 pi over the absolute value of b. Okay. So on these questions, what you want to do, and the way they have this worked, you just want to pick the positive one for b. We already know that the phase shift, or sorry, the period is 2 pi, right? So this is 2 pi over here. So we know that the period is 2 pi, and so place that in for the period here, and then just solve for the absolute value of b, okay? So I can write this as a fraction and cross multiply. I get 2 pi times the absolute value of b equals, cross multiplying here, I get 2 pi. All right, next up, divide both sides by 2 pi. So I get the absolute value of b is equal to positive 1. Okay, so that means that b is equal to 1 or minus 1. And so on the period for these problems, just pick it to be the positive one, okay? That's what you should do. You can pick it to be the negative one, but then that's going to make things a lot more complicated, and I kind of doubt that on the Newton problems that they account for that, okay? So don't do that, okay? Just pick the positive one on the value for b. Now on the a one for the amplitude, you're going to have to look at the graph and decide which one you need to pick based on whether it looks like the basic sine or cosine. All right, and so now is the phase shift. The phase shift, remember, is the formula for that is c over b. Okay, so remember that formula depends on you writing sinusoidal functions like this. If you're using some other reference, they might do this with a plus, in which case it's going to be minus c over b. So just be careful about that. On the Newton ones, they'll always assume it's written like bx minus c. So previously we calculated the phase shift, right, to be minus pi over 2. C, we don't know, right? This C that we're looking for here, we don't know what that is. And B, we calculated it to be 1, right? So we'll get this little equation involving C, and we just need to solve it. Here, there's really nothing to solve, right? Because over on the right-hand side, we have C is equal to minus pi over 2, right? And so that's what C is, all right? So now we know what B is. B is 1. C is minus pi over 2, right? And so that is all that we need to finish off our answer. So go over here. All right, B is 1, so it's going to be 1x minus and then it's going to be minus pi over 2. Let me put that in. And I don't know how picky Newton is about the answers, but I would write that as a plus, right? X minus a negative pi over 2 is the same as x plus pi over 2, and that's simpler, right? Okay, and so that's what you will need to put into those answer blocks, and then hit submit, and it's good.